Hello friends, this is Sai Fanindra from SQL School. I assure you complete practice-oriented lectures with real-world implementations and end-to-end project implementation. Come on, let's get started with our beautiful, colorful course box number 6, Azure Data Engineer. What we do, what exactly we do here at our job desk as a Azure Data Engineer. Let's get started now, exploring all the job activities step by step. And before we start the prerequisites for this course, we need to have some basic knowledge on SQL Server Transact SQL. Why we need to have that knowledge? Yes, basic knowledge is required. The main reason, number one, yes, any SQL is required basically because we need to understand about something called U-SQL, NoSQL, KQL, SAQL. There are some querying languages. So any SQL is okay. Prefer to know some basics on SQL Server TSQL for two reasons. Number one, our course includes Synapse. It is basically a data warehousing environment, and the Synapse data warehousing environment works on this one, this dedicated SQL pool, formerly DW. So one of our primary component in our course, it works on Transact SQL, TSQL. Number two, the data factory. Azure Data Factory tuning and auditing activities. The Azure Data Factory tuning and auditing activities also have some dependencies on the Transact SQL components. So one reason, SQL pool called data warehouse, another one, data factory. For these two reasons, good to have some basics on SQL Server TSQL, concepts like joins, constraints. It should be fine to step into data engineer. So what we do as a data engineer? Let's get started now, carefully, step by step. Well, so here we go. Before we get into the job roles, let's get some basic idea on what is Azure Data Storage and what is Azure ETL, and then what is Azure Data Engineer. Before that, cloud, a platform to ensure 24/7 access to your data, accessible across various browsers as well as tools. For example, in our course we need to work with something called Visual Studio for data lake and analytics, data lake storage and analytics. We have something called Visual Studio tool. Same way, we have something called Azure Data Studio tool. This is used for Synapse database as well as a regular SQL, Azure SQL database. We can define Transact SQL queries as well as new notebooks. And we have Azure Storage Explorer tool to store huge volumes of data. These are all the free tools from Microsoft and we need to use them, in addition to the data access from Azure, from browsers. So the benefits of cloud: no physical infrastructure is involved, everything virtualized, easy to use, easy to manage, easy to secure. But yes, we need to pay a bit more to enjoy more security. We need to be a bit more to Azure to enjoy more security. Not only Azure, any cloud provider, the same process. We want more, we need to invest more. Automated service packs and app upgrades. So automated maintenance activities, really a nice news for us, a good news, as would be involved in data storage activities next. There are three popular providers when it comes to the data engineering environment. We have Azure, Microsoft Cloud, Google Cloud, AWS Cloud, Amazon Web Services. Out of this Amazon, Google and Azure, yes, prefer to go for Azure. Number one, easy to use. Number two, comparatively cheaper. Number three, highly secure. We store any type of data, any type of application, and easy to secure, easy to store and integrate. With this information, there are different implementation types in Azure Cloud. We have SaaS, software as a service, 100% cloud, and no software to be installed, and completely logical computing. Cloud computing is logical. I mean, Azure will take care of all the operations. Platform as a service, 80% cloud and 20% non-cloud. So most operations are cloud-based and may need to install few integration components. Like for example, there is something called as integration runtime. It is required mainly for data factory. One ETL component called data factory. We need this integration runtime, a free tool. To access non-cloud data to cloud, we need this component, a free installation from Microsoft. These type of examples come under PaaS. And third, IaaS, 50% we manage, 50% Azure will manage. So the hosting operations will be in cloud. Monitoring, management would be in non-cloud. So hosting in cloud, monitoring and management can be from non-cloud, or the same manual activities as well. In our course, we'll be understanding about VM, virtual machines, that talks about this IaaS implementations. With this basic introduction for last 5 minutes, let's understand what we do as an Azure data engineer. Remember, we have 4 pillars. Number 1, first pillar, storage. Second pillar, ETL. Storage requires security and optimizations. ETL requires optimization. So in our journey as a data engineer, our actual day-to-day job work involves these 4 pillars: storage, ETL, security, optimizations. And in this process, we need to come across monitoring activities, processing, decompositions, analytics, polybase, clusters, and so on in our lengthy course. Mostly it is all about storage, security, ETL, optimizations. ETL means extract, transform, and load activities. You extract, transfer, you extract data from multiple data sources, transform, rearrange, shape it in a way you actually wanted to, and then load it to the destination site. A common destination in our Azure data engineer environment would be Synapse, a warehouse. So what we learn? Here we go. What we learn? We learn 9 different components. Storage, Azure storage for binary large objects, tables, queues for message activities, messaging, and file share, a regular file share, which can be used to dump the data, something like this. Here we go. For example, a Azure share can be looking something like this: SQL school storage account .file.co.windows.net and Azure, something like So we have four different types of storage in Azure storage account. Then we have data lake storage called Gen 1 for blob storage only. Cosmos storage for document databases, we call it as multi-model database. Synapse for data warehouse databases, for relational and historical data. And we have data factory, simply say for cold or old and historical data. Data factory for ETL, integration of Azure services. What do we mean by integration? Yes, for example, inside data factory, let's put this way. Let me take you to the Azure environment that we are going to practice in next classes. Go to Databricks, notebooks, jar, Python, etc. Inside data factory, we can use Databricks, we can use data lake. Databricks and data lake are both having their own storage plus ETL, extract, transform, load components. Additionally, they can be controlled, they can be integrated inside the data factory. So these two are the main base activities. Next, apart from this, we also have additional storage components. Here we go. Inside data factory is a main ETL component that includes additional storage components that can be used for data extraction stage or reporting or say loading activities like blob, Cosmos, data lake Gen 1, data lake Gen 2, Azure SQL database, regular SQL database, Synapse analytics, Azure tables, blob storage, Azure search, and so on. Good amount of products can be supported for ETL components, drag and drop, codeless in data factory. So data factory is one of the main core item in our course, and it has its own expression language plus supports transact SQL. Data lake analytics for something called catalog databases and ETL analytic activities. And we have Databricks for storage, ETL using Spark. And we have Stream Analytics for storage, ETL, analytics, as well as live streaming data. We have Azure Monitor and Azure Functions, mainly for monitoring and metric activities. So different type of services, Azure services, different purpose and the appropriate platform to carry out these activities. So here these components can be broadly categorized into three different items: storage level, ETL level, analytics level. There are storage components, ETL components, and analytic components. Analytics are more into reporting activities. We have storage, data lake, more into storage activities, data lake analytics, ETL and analytics, Databricks, all three, Cosmos, storage and ETL, Stream Analytics, ETL and analytics. Then we have event hubs, something called IoT, Internet of Things, which are complete into storage. Synapse is into storage and analytics. For ETL components with Synapse, mostly we use data factory. And for loading the data into Synapse, we require an internal component called Polybase. So here data factory is mainly used for integration of other components, the main gel for end-to-end implementation process. With this information, let's come back to our main curriculum page again. So we are into box number 6. How box 6 can be communicated with 4, 5 or 7. And what is 8, the Azure BI? If you go to the Microsoft Business Intelligence, azure.microsoft.com BI, and there you'll see the implementation in this way. Data factory and data lake storage, Databricks, Cosmos and data lake analytics together is equal to this box number 6, data engineering course. This is this particular window, Power BI. This is box number 5. Whereas the complete information is box number 8. Have a look at it now. What are these box 6, 5 and 8? Yes, here we go. 6, Azure Data Engineer, core storage, ETL, security optimizations. Then comes 5, Power BI, or mix of everything. 8, Azure BI. How data engineer and Power BI are related with each other? Yes, for example, you take something called Cosmos database. In Cosmos database, you see that the Cosmos DB is used to store the data, and from there we use something called Python notebooks and visualize the data or give the data to Power BI. Same way, for example, Databricks. Coming to the Databricks, we have the end-to-end integration examples in this way. So story starts with data, ends with Power BI everywhere. For example, we have something called Azure storage. For Azure storage, again, there are different types of storage: binary large objects, tables, file share and queue. That data, blob and Azure table data, is given to Power BI in this format. Have a look at it now. With this information, so our course would be completely into practice mode, right from the very basics. I assure you 100% practice orientation. And we'll be starting right from the very basics of our course, right from the basics of Azure, to slowly step into the Active Directory and other basic fundamental concepts, then into security and Synapse, storage, data lake, Cosmos, Databricks and stream analytics. To make it clear and simple, let me just put this way on my screen. Yes, a complete synopsis. So we'll be starting with fundamentals, security, slowly get on with migrations, and then Azure Data Engineer, big data storage. We'll understand about various type of data storage and security concepts, like we have something called role-based access control, RBAC, ACL, access control list, access keys, SAS keys, shared access signature keys, etc. We need to understand about various ETL components, ETL techniques, incremental loads, and optimization techniques as well. So different components, storage and ETL. There are two different components here, storage and ETL components. Coming to storage, we have total of 6 different components. File, table, queue, shares, data lake storage for files, data lake analytics for catalog databases. These are a bit similar to SQL Server, wherein we see something called master and other databases. It supports a language called U-SQL, which is actually a combination of transact SQL with little bit of .NET. But yes, basics of SQL Server should be fine to step into this beautiful course, a useful course. We have Databricks that stores something called DBFS, Databricks file system, a automated clustered environment to store files and tables. That works on Scala, Python, R, etc. Here it is. As a data engineer, of course, if you are into Azure, it's a developer course. If you are into Azure developer program, Azure 204, then you may need to have more hands-on with Python, R, Scala, Spark, .NET, etc. We are into Azure Data Engineer DP 200 201 certification exam pattern, and basic knowledge of Python should be fine to step ahead, to go ahead into our job work. So that required knowledge of Python would be taken care in our course across 5 different sessions. 1 for Cosmos, 4 for Databricks. We'll do it carefully. Again, out of these 4 for Databricks, 3 would be for core Databricks, 1 would be for Databricks with Data Factory. Integration activities. So whatever knowledge we are learning here should suffice our job work as an Azure Data Engineer. If in case you are looking for more into programming, then we have a separate course, Azure Developer, a separate 3 months course altogether, Azure Developer. We have SQL Developer over there, then Python, then R, etc. For now, yes, we are staying concentrated with Databricks and the required knowledge for data engineer, storage, security, ETL optimizations. And we have Azure Cosmos database for document database, multi-model activities, which means it supports multiple levels of data. We call it as a multi-dimensional data. For example, assume a product has some properties like size, price, and weight, etc. Again, and color. Inside the size, you got subcategories, small size. Again, variations, big size, variations, extra small, variations, extra large, variations, etc. So when one document is resolving to other multiple sub-documents, we require Cosmos DB, multi-language environment. For example, something like this on the screen. Let's take a NoSQL database. A basic example showing you right now here. And we see something like this. Shipping contains weight and dimensions. Dimensions contain something else inside again. This type of multi-level activities are supported in Cosmos database and Synapse database for data warehousing environment. ETL components, we have data lake analytics, stream analytics, that includes stream analytics query language SQL with Internet of Things and event hubs, Cosmos database, Python, .NET, C#, etc. Databricks with R, Scala, Python, SQL notebooks, and Data Factory. Codeless and drag and drop in Azure, completely drag and drop. and it supports MSBI, SSIS as well in case if you are into Azure BI. Next, main advantage of Data Factory, it can integrate Databricks, Cosmos, Analytics, everything can be integrated inside a single nutshell, Data Factory pipelines. And we need to understand in our course about monitoring activities, end-to-end implementations. For example, you have Cosmos with Power BI. Same way, we have storage with Power BI. For example, something like this, storage with Power BI. Or for example, you have Synapse with Power BI. In this way, back to my screen. Every storage activity requires data source connection configurations. We need to have knowledge on that for Power BI and other analytic tool integrations. Lastly, our course includes guidance for DP200 and DP201 certifications. I assure you once again my complete commitment on step-by-step understanding of our entire course. You may opt for number 1, just in case. You may opt for Azure Data Engineer course, Plan A, or Plan B, Azure Data Engineer plus Power BI, Data Engineer plus SQL. Plan C would be Power BI. There are 6 weeks Data Engineer course, extra 2 to 2.5 weeks for SQL, another 4 weeks for Power BI. So our concept should be something like this: fundamentals, then comes the Data Factory and Synapse, Databricks, Cosmos, Stream Analytics, and Cosmos with Stream Analytic integration activities and end-to-end project work. The detailed curriculum is available on the website as well as here also. Planned for about 6 weeks, 1.5 months if it is regular course. If you are planning for weekend, it will be for 2 months. Or if it is on-demand videos, it's up to you, either live or on-demand videos. If it is on-demand videos, you can access at your own comfort levels. You'll be given the required username, password from our website. And here is the lab plan. To do justice to all components in Azure Data Engineer, we have specific lab plans in place with complete practice approach. And with this information, we look forward for your registration on either live or on-demand videos or classrooms. And I strongly request you to make sure you have time to practice at least 45 minutes to 1 hour every day throughout the course, so that our course would be very much useful directly at our job desk. With this information, we'll stop for now, and I shall wait for your doubts and clarifications on email or call. Thank you very much. Have a nice time. Thank you once again.